Hello guys, welcome back to Unit 4 of the Advanced Java course. This is the final unit of the course, so congratulations on making it this far. So in this unit I'm just going to teach you some sorting algorithms and recursion. And this is chapter 1. We will just go over some basic sorting algorithms. So the first algorithm I will teach you about is the bubble sort algorithm. The bubble sort algorithm just repeatedly compares items next to each other. So the larger items bubble to the right, but the thing is the bubble sort isn't very efficient, so it's best used for smaller sets. So we'll be seeing the algorithm in action pretty soon. So first we're going to import scanner and to receive input for the user. And then we'll ask how many numbers they want to sort, and we'll store it in the variable n. So next we'll create an integer called input to receive the numbers inputted by the user, and we will input the n numbers they want to sort. So to receive the input, we will create a for loop as follows, and we'll store the numbers received in the array we created above. So this is the code right here. So then we're going to move on to a method to print the array. So we're going to let's name it numbers, and we'll create a variable called length, which is the length of the array. So using a for loop and a system.out.println, we're just going to print the numbers in the array. Now to actually use the bubble sort algorithm, we're just going to create the bubble sort method here, and we will use the numbers array we created earlier, since those are the numbers we want to sort. We will create a variable n, and if you remember from earlier, n is the number of numbers that the user inputted. So we'll set it equal to the length of the array, and in a for loop we will scan over the elements in the array, and then we will declare a variable called pass, which is the number of times the for loop will run to sort the numbers, and we can run it as many times as there are numbers. So we'll create another for loop within this to check the value of the current element with the value of the next element. So we'll name this variable current, and it will go from the 0th element to the last element minus the number of passes. So using an if statement, we will compare the current number with the next number right here, and we're going to call it the temporary variable temp and move on to the next number. And if we haven't created a temporary variable, we would have lost the current number, so it's important to create temporary variables so you store the value of the number in the array. So lastly, we just have to print the sorted array to the user, and we will create the sorted array by using the bubble sort method on the input array. So, and then we're just going to use print array to print it, which is put in this static void main method here. So let's run the program. We'll just do 5 numbers. We'll start with 12, 90. And as you can see, it works. So now we're just going to move on to selection sort. And selection sort basically works by moving the smallest element to the beginning of the array and repeating this until the whole list is sorted. So again, it's not very efficient for larger arrays, but it doesn't stop right after the array is sorted. It runs through every single value. So we're going to create a new class right here, and the code we will use for the algorithm will be very similar to the bubble sort code, except for a few small changes. We can copy and paste the code from the last algorithm. I've already done it here. But you're going to have to delete the first part of the code from the main method upward, and we're going to have it be named selection sort instead. So again, we're going to import scanner so it can receive the input, and we already have the method to print the array, exactly like bubble sort. So we will print the numbers the user inputted using the print array method we created above. Next, we're just going to we're going to work on the selection sort method and work out the nuances between selection sort and bubble sort. So in a for loop, we're just going to declare a variable called index and initialize it to 0 because arrays always start with an index of 0 in the array the user's inputted. Then we will declare a variable called smallest index right here, and we will set it equal to the index of such number. After that, we will create another for loop inside this one for the current number we're looking at in the array for each pass, and we will set the current equal to the index plus 1 because the current is 0, and we already set that value equal to the smallest value. So using an if statement, we will compare the current number with the number we call the smallest value. And if the current number is less than the smallest less than the smallest value, we'll set the smallest value equal to the current value, and so on and so forth for the rest of the as it cycles through the array. So next after that we're just going to make a number with an index of 0 equal to the smallest index of the value, and then we'll just have to return the array right here. So let's run the program again. We'll do 4 this time. 98, 43, and 1. And it works. So the last algorithm that we're going to go through is the insertion sort. And the insertion sort algorithm works by passing through the array only once and placing each value in its proper spot before moving on to the next value. So it's pretty efficient for sorting smaller arrays, but again, like the other two, it doesn't work too well for larger ones. So again, new class here, and we can again copy some of the code, including the print array, and we're just going to change the name to insertion sort. So let's start working on the method. Right. So let's declare a variable called n for the length of the numbers array, kind of like the bubble. Next, we'll create a for loop to initialize the index to 1, because we'll start from the second number. And we'll need to create a variable to store the values of each element in the array in each run. So we call this variable key. Initialize key to the value of the number with an index of 1, which will start with a loop. And then we're going to need another variable to store the index -1 right here. So next, we're going to use a while loop. We'll move the numbers in the array that are greater than key to 1 position forward. So while the current index is greater than or equal to 0, and the number at that position are greater than the key, we'll continue moving the numbers forward. So we'll do this by setting the number at each position equal to the number at the current position, and then finally we're just going to set the number before the current number, and this will repeat until the array is completely sorted. So let's just run the program. We'll do 6 this time. We're going to do 32, 1, 67, and it works. That's some basic sorting algorithms. So next I'm going to teach you about recursions and heaps in the next chapter, and once you learn that, we'll go over more sorting algorithms that use recursion and heaps. Okay?